Let's talk about how to perform conversions. So first, let's look at an example that is a little bit straightforward and some of you may have seen before. It says there are 12 inches in 1 foot. How many inches are there in 3 feet? So most of the time, if I ask this in class, people can tell me pretty quickly that it's 36 inches. And they're telling me that they can get this by just multiplying. So you can do the 12 inches times the 3 feet to get the 36 inches. So what we're going to do today is learn about dimensional analysis or unit analysis, which is a little bit more formal way to talk through this process. So dimensional analysis is used to convert between two units. In dimensional analysis, we multiply by one or more unit fractions to cancel out units. A unit fraction has two properties. The numerator and the denominator contain different units, and the value of the unit fraction is 1. So if we think about that example we just saw, they told us that there's 12 inches in 1 foot. So there are two different unit fractions we could write from this information. We could write 12 inches over 1 foot, or we could write 1 foot over 12 inches, right? The numerator and denominator contain different units, but the value of this unit fraction is still 1. Because remember, when we have a fraction like 7 over 7, right? When we divide anything by itself, it gives us 1. So 12 inches and 1 foot are the same thing. They're equivalent. So when we divide them by each other, they still give us 1. Now, if we were trying to do that problem from before, where they asked us how many inches are there in 3 feet, what I would do is start with the 3 feet and write it as a fraction. I can take any whole number and put it over 1 to make it a fraction. And then what I would do is multiply it by one of these two unit fractions. Now when I do this, right, our goal is to cancel out the units. So remember when we're multiplying fractions, if I did something like 1/2 times 4/9, I could cancel out the 2 and the 4 because they're diagonal from each other. I could say 2 divided by 2 gives me 1, 4 divided by 2 gives me 2, and then multiply straight across to get that answer of 2/9. So I'm going to use the same logic here, where to cancel stuff out, I need the same thing to be diagonal from each other. So since feet is up top here, I need feet down in the denominator in the bottom here. So that's telling me that I'm going to choose this unit fraction that has the 1 foot in the denominator and the 12 inches up in the numerator. When I do that multiplication, the feet are going to cancel out. And when I multiply straight across, I'll end up with 36 over 1, which I know is the same thing as just 36. And the only units left are inches, so I have inches in my final answer. Now let's look at a few other examples. We have 70 inches to feet, so we're going to be using that same conversion, 12 inches in 1 foot. Now if I look at this, I'm going to start with my 70 inches over 1. And I need to multiply it to cancel out those inches to get to feet. So if I do that, I know I'm going to want inches in the denominator, so the inches will cancel out, and feet up in the numerator. So it was 12 inches, so I'm going to put the 12 attached to the inches, equals 1 foot, so I'll put that 1 foot up top. When I multiply straight across, that gives me 70 over 12 feet. But I don't want that, so I'm going to use my division because I know a fraction bar means division. I'll do 70 divided by 12. And that tells me that I have 5.83 repeating feet. Now, I believe our homework typically asks us to round to the nearest hundredth, or sometimes it might say to 2 decimal places, because that's 2 digits after our decimal point is our hundredth place. So if we do that, that 3 repeating, right, is really telling us it's 5.83, 3, 3, 3, 3. The 3's keep going. So if we're rounding to the hundredth place, the 3 tells me to leave that 3 alone. So I'd say that my answer is 5.83 feet. If we look at another example, they're asking us to convert 4 quarts to fluid ounces. Now I copied the piece from our conversion chart onto my slides so that you could see it. But I definitely recommend while you're doing the homework, have that conversion chart handy. Okay, so I'm starting with 4 quarts, so I'll put 4 quarts over 1. Now, there's an issue that we didn't have before. If I look at my conversions, I have 1 quart equals 2 pints, and I have 1 gallon equals 4 quarts. I can't go straight from quarts to fluid ounces. So what I'm going to do instead is try to figure out how I can get there. So I want to end here with fluid ounces. So the only way to get to fluid ounces is from cups. And if I look, I can go from cups to pints, and I can go from pints to quarts. So those are the conversions that I'm going to use. And I'm going to kind of write out my process so that I don't forget what I'm doing. I'm starting out with quarts, and from quarts, I'm going to go to pints using this conversion. Then I can go from pints to cups using this conversion. And once I'm in cups, I can go to fluid ounces using this conversion. So I'm going to have a multi-step conversion here. And I'm going to write it all out and then do my multiplication at the end. So if I want to go from quarts to pints, I want quarts in the denominator and pints up in the numerator, so my quarts will cancel out. And I know from right here, there's 1 quart in 2 pints. So I got to pints. Now I need to get to cups. So I want my pints to be in the denominator so they'll cancel out, and my cups to be up in my numerator. So using this conversion, there's 1 pint in 2 cups. I got to cups. Now I want to get to fluid ounces. So I want my cups in the denominator and my fluid ounces up in my numerator. From that conversion up top, I know there's 1 cup in 8 fluid ounces. So I'm going to multiply straight across. I'll have 4 times 2 times 2 times 8, which gives me 128. 1 times 1 times 1 times 1 gives me 1. So I'll have 128. The only units that didn't cancel out are fluid ounces. Now, when we're talking about conversions, we also have to think about the metric system. The metric system uses prefixes combined with a base unit to name different units. So our prefixes are K for kilo, H for hecto, DA for deca, D for deci, C for centi, and M for milli. Our base units are M for meters, G for grams, and L for liters. So if we were talking about all of these units with meters, I would just stick an M after all of them. If I wanted to talk about the same thing with kilograms or hectograms or decagrams, right, I could keep going and just put a G after all of those prefixes. And same things for liters. I would just put that L after everything. And you can use an uppercase L or a lowercase L, either one. So it helps to know that this kilo is the biggest and the milli is the smallest based on the units we look at. They do go smaller and bigger. And if you want help remembering this, I use the acronym or the saying that King Henry died Monday drinking chocolate milk. And when I use this Monday, I know that it's standing for meters, but it could also be grams or liters. The other thing I want to warn you to be careful of is don't get deca and deci mixed up because they both start with the D's. Remember that deca has that A in its prefix. So if we look at our examples, we're going to convert 7.5 kilometers to meters. So I know their metric. So I'm going to use that King Henry died Monday drinking chocolate milk. Now these have meters after them, so I don't want grams, I don't want liters, I want meters after all of it. Now if I look at this, they're telling me that I'm starting at the 7.5 kilometers and I want to end over here at meters. So it's telling me to go 1, 2, 3 spaces to the right. So what that's really telling me to do is to move the decimal point 3 spaces right. So I have the 7.5. I'm going to go 1, 2, 3 spaces right, and I fill in those blank spaces with zeros. So I know that 7.5 kilometers is really 7,500 meters. I'm going to look at the same thing with this next example. So I have 1,973 decagrams to hectograms. So I have King Henry died Monday drinking chocolate milk. This time everything has a G after it, so I don't want meters, I don't want liters, I want grams. They're telling me to start at decagrams and end at hectograms. So I'm going 1 space to the left. So just like before, that's telling me that I need to move the decimal point 1 space left. So I have that 1973, that 1973. When I have a whole number, there's no decimal point written there. So I know my decimal point is really at the end. I'm going to bump it 1 space to the left. And if I do that, it gives me 197.3 hectograms.